So one of the tools that we can use in an asynchronous setting, especially with our hybrid learners, is something called a think, pair, share. Now, for those of you that may not have ever used this method before, a think, pair, share is basically an article that you may have already used in the past or one that you recently discovered. And you basically ask students along the way questions in a way to basically create a self-dialogue or a dialogue within a smaller group of students. And what it also does is it allows for them to basically read short bursts of information and analyze them step by step by step. So the example that you see here is a think, pair, share that I've used in the past. Being a world history teacher, I have to cover more than 700 years of history in a very small window of time. So what ends up happening is one of the first units that I cover is the age of expiration. But the age of expiration was the brainchild of the Renaissance. And I really can't discuss the Renaissance without delving into the Middle Ages, the medieval period in Europe. So obviously, I don't want to spend that much time on medieval Europe, but I do want to give them the basic information, what life was like, and how the way that life was back then would eventually lead to the rise of urban centers and especially the rise of the Renaissance. So what I devised was this little activity that the students complete in about 25 minutes. So in essence, I cover about a 600-year window in the span of 25 minutes with this think, pair, share. So I found this awesome article once that breaks down the medieval era. So looking at this, what I ended up doing is as I said in the PowerPoint before, what ends up happening is you have an article and you break it down every couple of paragraphs. And then what you do is after a couple of paragraphs, you create a break and you, in essence, create a series of tasks. So what you end up doing here is let's say you have your article in Word, you go to insert, you create yourself a table. In this case, for me, it was a 2x2, as you can see here. And then from there, I go into the box and I create my questions. Now, as you can see here, my questions do follow a level of Bloom's taxonomy, where we start off at the most basic level and work our way up. So one of the first questions, it was a description of why were there two Romes and what happened to each. It's absolutely imperative to understand this aspect of the medieval ages because this is what kickstarted it. There used to be the Roman Empire and then it was split into two, the East and the West. The East would live on until 1453 and the West, within a couple centuries of the split, would completely crumble and fall apart, leading to the Middle Ages in Western Europe. And so the next question that I have here is for them to basically draw an inference, to basically be like, okay, I've kind of given you a hint as to what life was like, but take it a step further. On a day-by-day basis, what was life like for these people living in Western Europe? And obviously having to use text citations. From there, one of the most key important aspects of the Middle Ages at this point was self-preservation. The ability to know that, hey, you will rise to see the sun tomorrow. That was one of the most important things on the day-to-day basis for people that lived during the medieval ages in Western Europe. So I kind of asked them to analyze it. Why was self-preservation so important and such a major concern for people at this time? And this explains why systems like serfdom existed, that people openly gave up their freedom to have the protection of a king or a lord or a knight. Because without that protection, Yo-Yo Bumchuck can come at you and come after you and, take your possessions, kill you and your family, just something you don't want to even imagine. So this is why, after quick analysis, you can see why people lived the way that they did and systems forms the way that they did. So notice how these tasks build up to a crescendo. And that ends off with an application where, okay, looking at what you've done here, how can you apply what you know and create something with it then? It could be something as simple as, hey, just create a slogan as you see here. So you can structure your questions here any which way you want. And it really all depends on how you're using this. Is this introductory? If it's introductory, I would humbly suggest that maybe your questions shouldn't be that far advanced. If it's something that you're doing at the halfway point of a unit, where it's like, okay, we've learned enough about this, start applying what you know and connect it to what you're reading here. Or if you want to have this be an assessment, maybe you have them specifically, use specific pieces of evidence from what they've known to apply it here as well. Whatever the case may be, you can structure your questions to any level that you want. And the best part about it is the fact that this is an individualized discussion. You're basically telling them, read this and self-reflect using these questions, which is, you can see why this could be so useful when you are in an asynchronous session. So let's look now and see how exactly one can create a think, pair, share for any field, because I strongly do believe that a think, pair, share could be used in mathematics. It could be used in CTE learning. It could be used in dance and music, whatever the case may be. It is an activity that, quite frankly, can be applied to almost anything. So that being the case here, I found this very interesting article before I started recording this video on how a mathematician from the 19th century showed us the best way to hold a slice of pizza. So that being the case, what we have here is this article here, and I'm just gonna read with you, and I'll show you how you can go about creating a think, pair, share just right off the top of your head. So let me begin. So we've all been there. You picked up a slice of pizza and you're about to take a bite, but it flops and dangles limply from your fingers instead. The crust isn't stiff enough to support the weight of the slice. Maybe you should have gone for fewer toppings. Maybe you shouldn't order that Hawaiian pizza, just saying. But there's no need to despair. For years of pizza eating experience have taught you how to deal with this solution. Just fold the pizza slice into a U shape, AKA the fold hold. This keeps the slice from flopping over, and you can proceed to enjoy your meal. Now, if you don't have a slice of pizza, unfortunately, in hand, you can try this with a sheet of paper. Behind this pizza trick lies a powerful mathematical result about curved surfaces. One that's startling, that its discoverer, the mathematical genius Carl Friedrich Gauss, named it the Theorema Egregium, which is Latin for excellent or remarkable theorem. Take a sheet of paper and roll it into a cylinder. It might seem obvious that the paper is flat, while the cylinder is curved, but Gauss thought about this differently. He wanted to define the curvature of a surface in a way that doesn't change when you bend the surface. If you zoom in on an ant that lives on the cylinder, there are many possible paths the ant could take. It could decide to walk down the curved path, tracing out a circle, or it could walk along the flat path, tracing out a straight line, or it might do something between, tracing out a helix. Gauss's brilliant insight was to define the curvature of a surface in a way that takes all these choices into account. Here's how it works. Starting at any point, find the most extreme paths that an ant can choose, i.e. the most concave path and the most convex path. Then multiply the curvature of those paths together. Curvature is a positive for concave paths, 0 for flat paths, and negative for convex paths. And voila, that number you get is Gauss's definition of the curvature at that point. So let's say that, I want to create that break here, and I want to create my box for my think, pair, share. I go to insert, I go to table, and let's say I want to create 3 questions. Let me show you this, because 4 is easy. You just create a box that's 2 by 2. But let's say you just want to create, an odd number and have it be 3. Let me show you how that could be done. So we create a little box. There it is. And maybe one of the first questions I want to ask my students is, why does the author bring up the example of picking up paper? Pretty simple, to the point. And by the way, just want to bring this out to you once more. If you haven't already noticed, this is a math article. So just to come to show you once again that this can be applied anywhere. It's not just something that's for the humanities. So why does the author bring up the example of picking up paper? Maybe the next question could be something along the lines of, hey, apply Gauss's theorem with actual numbers to define a curvature. Notice here how maybe this is something that we've already discussed in class. And you can basically tell people, okay, well, listen, we've already looked at hyperbolas and so on and so forth. Let's actually look at what Gauss is saying here and actually apply to mathematics. Let's actually plug in numbers and see if we can truly create a definition for curvature at a specific point. Awesome. Okay. And that could be our second question. And let's say we want to create this last one. Well, this is a really cool thing that you could do here. You can basically merge these cells together. And there you go. Now you have your third box. And let's say that maybe you want to take this and ask your students to reflect and maybe find a real world application. So maybe your question could be something along the lines of something like this. Other than pizza, where else can this be applied in the real world? Now, I'm not gonna lie to you, I really don't know what the answer would be. My assumption would be maybe it could be in civil engineering with the building of tunnels, roadways on specific, curves and whatever the case may be. I mean, I'm not gonna lie to you, that's not my forte, so I'll just stay in my lane. But the more important thing here is I definitely wanna show you here how you can take any article and apply and create a self-reflective, self-paced, asynchronous lesson, which quite frankly, like I said, it could be used in an independent fashion where you tell the students, hey, here's this think, pair, share, complete it on your own. It could be done collaboratively where you create breakout rooms and you ask the students to, work on this together. Or you can even do both where you can basically say, hey, for today's class, you folks are gonna be working on this solo and we'll be coming back to it later and we'll just have a class discussion on it. You can also do that. In addition, you can also actually use this as an assessment. How can you do so? Maybe, if with this example here, something you could do is maybe you can even add math problems that applies to what we've already learned from Gauss or something that you've already done earlier in the year. And they have to take what they've learned and combine it with Gauss's theorems. You could do something like that. It could be something to the sense where, they have to provide you specific instances from what they've already learned and tied to this article. Notice that is an assessment that, quite frankly, yes, they still have every resource at their fingertip, like they do for almost any assessment now. But now it isn't enough for you to know the material. You actually have to know how to apply it. So this is one aspect of an asynchronous activity that could be both a lesson, a learning activity, or even an assessment. Enjoy.